Hello, welcome to our surface area revision. So today we're just going to be kind of going over these 8 questions that I've posted on the classroom and on the website. And hopefully you guys do this before you watch the video. You do the questions before you watch this, and then you can compare your answers to it. But I'm going to go through all of the questions. I'm going to answer them, and I will answer them as if I'm using the cheat sheet as well, or the note sheet that you'll be allowed to take into your test. So for question A, what we're going to be doing is we're finding the surface area. Now, the surface area is the addition of every single face that the shape would have. Now, the thing is, when you're looking at the shape, like the actual image of the shape, there are certain faces that you can't see, but you know that they're there. Now, they need to be included as well. It's like if you could actually hold this shape, a three-dimensional shape, in your hands, and you could look at all the different surfaces, and you could figure out the area of each surface, what would the combined area be? Right? And so, one of the ways I like to think about doing surface area is this surface area. You have different views. You have a front view, you have a side view, or a left view, a right view, a back view. In fact, you know what? I might even put my back view up a bit further. Oh, back view here. Front, back, left, right, and then over here I'll do top and bottom. You've got six different ways you can look at the shape, right? And so for a shape like this is actually quite handy. So let's talk about our front view. A front view is made up of two shapes. We have a square here, and then we have a larger rectangle here. Now, immediately I can see in our bottom rectangle, we have a length of 7, but a width of an unknown diameter? Question mark. So, how am I going to be able to figure that? Well, I can see that these tick marks here are indicating that all these sides are 7 centimeters, which means that from here to here is 7, from here to here is 7, and from there to there is 7, which means that this is 21 centimeters. A bit small. Beautiful. 21 centimeters. Perfect. So, already, we can see that our front view has an area, a combined area, where we have this, which is our length times our width, and we have this, which is our length times our width. Now, both of these, we can say that the front view area is equal to, let's do the area of the square plus the area of the rectangle. Now, underneath that, we can say that our area of our square is 7 times 7, length times width, plus 7 times 21. 7 times 21, which is equal to 49. I'll just put it on my calculator. 7 times 7 plus 7 times 21 is equal to 196. 196 centimeters squared. Now, important, it's square centimeters, okay? I'll put this down a little bit. All right, now, we can deduce that our backside here is the same as our front side. So our backside is also 196 centimeters squared. Now, we can see the beautiful thing about this shape. This isn't with every shape, but our left side and our right side are going to be equal. So our left is equal to our right. So let's do our left and our right here. All right. So because they're equal, I can say 2 times. And now, how do we figure this out? We need, let's say we're looking at our right side. So let's say we're looking over here. Now, our right and our left are identical, but we're just going to look at our right for now. We're going to look at our right. Let's do it in, let's do it in pink, shall we? Right side. So let's have a look. We have here and we have here. Now, important, this side here, that's part of our top. Okay, so when we're looking at it from face down, that's going to be that part of that side. So our right hand side is these two right there. All right, so that is because we know that here to here is 7. We know that from here to here is 7. It is 7 times 16 plus 7 times 16. Okay, the other thing that you could say is you could add your 7s because you kind of, you can imagine taking this and you could bring it all the way to the 4th. So like you could always bring it out here. You could have one larger square, which is 14 times 16. But for simplicity's sake, we're going to leave it like this. So 2 times length times width, which is 2 times 7 times 16. So say area is equal to. So our area is equal to 2 times 7 times 16, which is 224. All right, so now we've got our 196 and 196. So I might even just also say front and back area is equal to 2 times 196, which is equal to 292. Now, I've done front and back, I've done left and right, and now I need to do top and bottom. Now, here's the interesting thing, right? This is why I really like this shape, is that if you looked at it from the bottom, you would see a 21 by 16 rectangle. And if you looked at it from the bird's eye, I'll even draw it out over here. Right? If you looked at it from the bird's eye, you would see where all of these are the same, and this is the same. Where this would be, what was it, 16, and this would be 21 made up of 777, right? So the bottom and the top are actually the exact same. It's just that they kind of look a bit different because you have an elevated platform. I reckon it's actually very, very cool. So it's also, like, funnily enough, um, it's very similar to working out the area of a cube. But it's just cool how even though you can, have an elevated platform, it may as well not be elevated, may as well be flat. You know what I mean? But I think, I don't want to confuse you too much, but I just think it's a really cool part of the maths where, even though it's elevated, if you look at it from a bird's eye view, it would look flat and you can kind of treat it as what's flat. I think that's kind of pretty cool. Anyway, so area of top and bottom. Now, we can work through them separately. We'll do that our top first. So our top, like we said, is we have 3 sections. So let's just get them in. What color should we use? Yeah, like lime green. I like lime green. Here, here, there. We have 3 sections. We can see that each of those sections, this is 7, this is 7, this is 7, and they're all 16 centimeters long, which is why over here we've got 3 sections, 7, 7, 7, and they're 16 centimeters long. Now, the area of the top, therefore, is 7 21 times 16, which this is also made up of 3 lots of 7 by 16. So we have our 7 by 16, which comes from one individual piece there. Now, because we have 3 of them, 1, 2, 3, 3 times 7 is 21. So that's why we have 21 by 16, which is 336. Now, for our bottom, we'll have a look at the shape again. Our bottom is length by width, which is 21 by 16. Area equals length by width, which is also 21 by 16, which is, again, 336. So the area of our top and bottom, 2 times 2, so I'll just okay, 2 by 336, which is 672. So our combined surface area, it's all getting a bit messy. So I'll just neaten it up a bit. I'll just yeah, move it up. Move you over. Put you down. All right. So our combined surface area is equal to the combination of all of them. So we need our top front and back, which is front and back here, 392, plus our left and right, which is 224, plus our top and bottom, which is 672. 1,238 centimeters squared. Beautiful. Question 1, done and dusted. All right, question 2. Now, we can see here we have 2 shapes. We have a half cylinder and we have a rectangular prism or a square prism. Not a cube. Okay, it's a square prism. It's a square face, but it is a prism. And a semicircle. So we can split them up. All right. So first thing we're going to do, surface area is equal to. Now, here's the tricky part, right? Is when you're doing a composite shape, even though you have these basic shape formulas, you need to be careful when you're using them. So here we can use the area, the surface area of a half cylinder, because if you have a cylinder, right, the surface area for a half cylinder kind of comes from the surface area of a cylinder, right? But when you're peeling it back, what happens is, I wonder if I can, like, be so cool if I could animate it on the go, but I don't think I'll be able to. Kind of what happens, right, is as you peel it back, you kind of get, let's just connect these, and then we'll connect that. So you peel it back, you get this, right? But what it fails to do is that that surface area doesn't count the fact that it says that there is no face. that the formula for the surface area of this half cylinder doesn't actually have that face there. But luckily, that face is actually covered by this box, and so we don't need it anyway. Now, what we're going to do is we're going to add, we'll find the surface areas of these faces. So, surface area of a cylinder. Let's do that first. So, surface area of a cylinder is half, well actually, what did I write in yours? I just wrote it pi r squared, or pi times r squared, plus pi times r times h. Now, generally, for a circle, right, this would be 2 times pi times r squared plus 2 times pi times r times h. Now, because it's a half cylinder, half of 2 is 1, and so you don't need to incorporate it, right? But it's important to note that pi times r squared is the area of a circle. So if what we're going to do is we're going to take this here, I'm going to show you. This is this part here, and the back face as well. Because if you combined those two areas, you would get a full circle, which is pi r squared. Now, 2 times pi times r. The perimeter of a circle is 2 times pi times r. So half the perimeter is pi times r. All right, and we're dragging that perimeter along the length here, which is 12 meters. So it is pi times r times the height, which is 12. Now, surface area is that plus all these faces here, right? So if we count the faces of our box, we have, let's do it maybe in dark green. 1, 2, this in here, 3, 4, and then we would have 5. Notice we don't have the top face, right? And so 1 and 3 are the same, 2 and 4 are the same, and 5 are the same. So we would have 2 times the length times width of 1 and 3 plus. So let's denote these. Front and back plus 2 times length times width. Now, our sides are the same. See, 1 and 4 are the same. Sides plus length times width of the base. All right, now we can kind of plug all that in now. So I'm just going to kind of write start over here. Okay, so pi, in fact, I'll go back to blue. This part here, pi times our radius. Now our radius is half the circle. So if this is 6, this is 3. So our radius is 3. Pi times 3 squared plus pi times 3 times our height, which is the height of the cylinder, which is 12. Then we're going to add plus 2 times length and width, front and back. So that's with our front face. Front here, length, width. 6 and 6. So 2 times 6 times 6. Then we're going to keep adding. Plus 2 sides here. 6 and 12. So our length and width are 6 and 12. 2 times 6 times 12 plus our base. Notice we only have one base, which is 5, which is 6 times 12 again. is equal to, now I'll do them in two parts. So I'll say pi times 3 squared plus pi times 3 times 12 is 141.37. And then I'm going to add, well, actually, let's make that blue. And then I'm going to add 2 times 6, 12, well, so 2 times 6 times 6 plus 2 times 6 times 12 plus 6 times 12, 288. Add those together, and our surface area is 429.37 centimeters squared. Okay, now there's a few steps. The thing with surface area is it's involved, right? There are a lot of different parts, but that's why it's really important to write it all down, because each little step on its own is really simple. You've got your length and width, which is the area of a rectangle. You just have to do it 5 times, right? And you've got the area of the half cylinder, which is a standalone formula, which you have in your worksheet, right? You just have to put that all together. It's just important that you recognize how many steps there are and how many faces that you're going to need to solve. All right, question C. This one, a lot of fun. All right, so surface area is equal to, let's split it up a little bit, shall we? So let's go, split it up this way. All right, so we have 1, 2, 3, 4, 5, 6. Then we would have on the back 7, and then we would have 1 again on this side, 2 again on that side, 7. So we'll even just, go like this. 7, 7, 9. Now, hopefully that makes some sense. Okay. The way that we're going to do it, it looks a bit hectic there actually. So maybe why even just we'll retry that. All right. I think I prefer the way that we're going to do it. I will split it up this way. So we're going to do it again the same way we were doing it before. All right. We can see we have our front and back would be the same. Okay. Now, interestingly again, our left and right would be the same. Because if you looked at the bird's eye view of your left, or no, not a bird's eye view, a straight on view of your left, it would look like you would have your little L-shaped box down there. Then you would just have this bit coming up there. And this would be 13, and this would be 4. So you would have it really, in essence, a 13 by 4 rectangle, which I reckon is very cool. So, actually, no, I'll leave that there. And then we have our top and our bottom. Top and bottom. Interestingly, again, these two are the same. If you looked at the top face, you would have your little L-shaped, block here. And then it would poke out. You would have that little bit out here. It would come down. And you would have this as 10 centimeters, and this is 4 centimeters. And you would have 2 separate little blocks, which is very cool, right? Now, these are kind of the easier ones. You've got 4 centimeters and 10 centimeters. The hardest part of this is, finding the front and back, because that's an addition of 2 separate things. But you'll see as we go through it, we'll end up highlighting and coloring in all of the different sides. So front and back. So we're going to look at the front because it's easier to see than the back, but our front is made up of two separate things. We've got this rectangle down here, and then we've got this rectangle along here. So that's going to do this. So the front and back is equal to, let's change this to equals, the pink area plus the red area. This is both. This is length times width plus length times width. Let's just take you and put you over here for now. All right. Now, pink area, we can see this is one, this is one, so that is one, and this is also one. So length times width is 1 times 10 plus length times width, which is 1 times 13. So the area is equal to 10 plus 13, which is 23 centimeters squared. All right, now let's look at our left and right. Oh, actually, that's the area of our front face. The area of the front and back is, just see if I can move this here, is 2 times this. It's 2 times this. So it's 2 times this. So the area is equal to, well, 2 times, sorry, 2 times 23, which is equal to 46 centimeters squared. My bad. I only was thinking about the front and I forgot to do the back. Now, that's why it's so important to remember and write down your places. You know, we're doing front and back. Okay, so left and right, because we're doing two. So our left and right, because there's two sides, we're going to do 2 times. Now, this is a rectangle, all right? It is a, even if let's say we're imagining we were looking at the right hand side here, so this side there, it would be a 13 by 4 triangle, right? Well, not triangle, rectangle. So 2 times length times width, which is 2 times 13 times 4, 134. Oh, no, not 100, just 104. Beautiful. And then here, our top and our bottom. Now, notice there's again 2 sides. So the combined area, this is here. Let's do it in red, shall we? No, blue. Is this here? And then I'll do that again and let's go lime green for this one. So here, should make more sense now actually. I should have done it color coded before. Do you see? Here, look. This is the 2 little rectangles made that have come together. This little rectangle is a 1 by 4. This here would then be a 12 by 4. Or we can just say it is the full length down. So if we just took that pencil, drew these across, brought it down, took it across, we would see that that rectangle exists, or that face exists there in that plane of view. And we can just say that it is 13 centimeters down and 4 centimeters across, which is what we've done right here. It is 13 centimeters down, 4 centimeters across. That is the same with the top face. If we're looking at it from a bird's eye view, if we're looking at it from a bird's eye view, we would see these two faces here and here add together to look like that. And so we have two of these faces. So it is area is equal to 2 times length times width, which is 2 times 10 times 4, which is 80 centimeters squared. So total surface area is equal to 80 plus 104 plus 46, which is 230 centimeters squared. Remember, squared is always really important. All right, let's do this. Question B. All right, well, initially I can already see that this question in itself has a problem. And now I don't want it to be too difficult. So what we're going to do is we're just going to, you might have got stuck on this. Now, if you've already attempted this problem, you will need to have actually used Pythagoras to be able to determine what the length of this side is here, because it isn't given. And you need to know what that is to solve for the area of the top rectangles. Yeah. But for the sake of this question, we're going to say that these are all 7 centimeters. Okay, there. So what that means is we have, let's count our faces. We have 1, 2. We would have, if I just go like this. All right, let's count our faces in pink now. We would have 1, 2. We would have 3, 4. We have a back face, 5. Now, notice these are all 7 centimeter squares, right? We also have this side face here, 6. And then we have this one over here, which is 7. So they're all squares. So our surface area is our combination of all the faces, right? We've got 6 faces. The only ones that we're missing are 8 and what would be 9 here, the 2 triangle faces. So surface area, we have a combination of 7 squares. So 7 times the area of a square plus 2 times our area of a triangle. All right, so surface area equals 7 times length times width plus 2 times base times height divided by 2. Now, I did that there just for like sake of purposes, but this also is base times height times a half. These are the same thing. I just did it because I was running out of space. So is equal to 7, and the length and width, it is a square, which is 7 by 7. So we have 7 times 7 times 7. Isn't that funny? Plus base times height. Now, our height of the triangle is 5. Our base is 7. Plus 2 times 5 times 7 over 2, which is 7 times 7 is 49, times 7 is, or 343. Let's have a look. Yeah, nailed it. Plus 2 times 5 times 7 divided by 2 is just 35, because this and this cancel, and 5 times 7 is 35. So our surface area is equal to 370, oh, 378, 378 centimeters squared. Not bad. 4 questions done and dusted, hey? All right. Now, it's just all about how you view these shapes, okay? They're all like the approach to every one of them is slightly different, all right? It's really a case of just how you see it logically, right? It's really important. Now, this shape here is going to test our ability to be able to use our area formulas and actually understand what they mean, okay? So, what we're going to do, surface area is equal to, what we're going to do, we're going to say surface area is equal to the surface area, well, let's do it in a different color, blue. The surface area of a cylinder plus the surface area of a rectangular prism here. This is the important part. This is the really important part. We're going to say take something away. Now, the reason is if we calculate the surface area of a cylinder plus the surface area of a rectangle, what we're failing to realize or recognize is that this face in here is not visible and it will be calculated. Now, the important part is it is not taken away once, it is taken away twice because it is taken away from the cylinder and it is taken away from the rectangle, the top face of the rectangle. So minus 2 times the area of our circle. Now, we can do this. We can do this because the beautiful thing is in our notes, we have all of the answers to this. Okay, not the answers, we have all the formulas for each of these shapes. All right, so we know the surface area of a cylinder is 2 times pi times, oh, a little r squared plus 2 times pi times r times h. Surface area of a rectangle is plus length times width times height. Now, 2 times the area of a circle is minus 2 times pi times r squared. Notice, look at this. This, in fact, I'll do it in red. I'll do it in green. This and this are identical. Well, not identical. Well, no, they are identical. This actually is identical to this. 2 times pi times r squared appears twice, but one is being subtracted from the other. So these cancel out. Isn't that awesome? When you write it all out straight away, you can see that. Now, I want you to know if you had just put all of your numbers in straight away and solved it without having cancelled it out, you would still get the same answer, okay? Doesn't change the answer. This is just something cool to notice as you're going through it. It's a really beautiful thing to do if you're writing it all out straight away. So here, now we're left with our surface area is equal to 2 times pi times r times h plus length times width times height. All right, now let's do this. Is equal to 2 times pi times, what's my radius of the circle? It tells me. Notice we're not having to halve it because it is actually giving us what the radius is, which is from the midpoint of the circle to the edge, times 9 times my height, which is 16 millimeters. Oh, I don't need to put the M there. Now, I just want to reiterate the reason we're not doing the area of the circles is because the formula for the area of a cylinder gives us the area of the top and the bottom, right? Circles. Now, we also need to subtract 2 identical circles because they're taken away from the bottom, or not, don't want that. They're taken away from the bottom here twice because you're missing the area of the circle from the base of the cylinder, but also from the top of the rectangle. And so they cancel out completely, which is why we don't have to calculate it. All right. Anyway, going on, plus length times width times height of our rectangle, which is 36 times 53 times 10. Beautiful. And then we can just put that straight into our calculator without having to do anything else. Is equal to 2 times pi times 9 times 16 plus 36 times 53. Oh, I put 63 in. Times 10 is equal to 1,000, oh, 1,998. Oh, never mind. 19,984.78 centimeters, millimeters squared. Now I rounded up to 2 decimal places. This is actually 778, but we round up. Awesome. Very, very similar problem. Okay. We have 2 cylinders. So our surface area is going to be equal to the surface area of the pink cylinder plus the surface area of the green cylinder. And then we still need to take away, it's not as clear, but it is sitting on top. And so this part here is not showing. And it's not showing in 2 places. It's not showing from the base of the cylinder on top, but it's also being taken away from the cylinder on the bottom. And so it is twice. Minus, it's the exact same thing that happened last time. 2 times the area of the circle. All right, so let's write it out again. It's quite a big formula, right? So we have surface area of a cylinder, which is 2 times pi times r squared plus 2 times pi times r times h. Now, we're going to do that again for the green cylinder. Plus 2 times pi times r squared. Keep going over here. Plus 2 times pi times r times h. And then one more time, minus. In fact, let's denote this. Let's call this R2, and let's call this R1. Just as a little, because here in the pink, we're talking about the radius here, but in the green, we're talking about the radius here. Okay, so just so we can have a bit of a separation, right? Minus the area of the circle, which is 2 times pi times r squared. But notice we're talking about the pink one, okay? Because it comes from the pink cylinder. We're not talking about the green one, right? So here again, notice, good and dark green. This is the same as this, and so they cancel. And we are left with our surface area is equal to 2 times pi times r times h, plus 2 times pi times r squared of r2 plus 2 times pi times r times h. Beautiful. Now we can start inputting our values. Is equal to 2 times pi times our r is 2 centimeters for the pink. See, 2 centimeters there. 2 times pi times 2 times the height of that, I should have looked, is 3. We've got two heights, but both of them are 3 times 3. Then we add this plus 2 times pi times our other radius, which is, 10 centimeters, plus 2 times pi times, squared, 10 squared centimeters, plus 10 times our height, which is 3. Again, we can just put this straight into a calculator because pi is an irrational number and it will always give us a really long decimal, so it's nice to just do it all straight away. 2 times pi times 2 times 3 plus 2 times pi times 10 squared. Important, remember this squared, right? Plus 2 times pi times 10 times 3 is equal to 854.51 centimeters squared. Beautiful. Look at that. All right. Last two questions. Here we go. We have question G. We have a cool looking T shape. Now, again, I'm going to approach this front, back, left, right, up, down, because I can already see my front and back are the same. I know that my left and my right are the same. And I know that my top and my bottom are the same. Now, that might still be a little bit confusing, but, right? Let's have a look. Our top, let's draw it out. Our top looks like this, just a straight T, just cross section, where we've got, this is 12, this is 1. Now, let's just kind of draw it in as well, right? If this is 4, all right, this is 4, and this, even though I didn't draw it that way, let's try it again. Let's draw a bit better, hey? There we go. These are the same, right? So the total length across needs to be 12. Here to here is 4. Oh, I won't put 4 there. There to there is 4. And these are the same. So 12 minus 4 is 8. And these have to be the same. So they need to be 4 each. Or half of 8. 4 plus 4 plus 4 is 12. All right. So we've drawn our top face. So this is the top. Now let's look at it from the bottom here. Let's look at it from the bottom. If we're looking at it from the bottom, you would see you have this face here, which is 4 by, even though it doesn't look like that, it's actually looking a bit more like this, where this is 4 and this is 1. Even though that's kind of, yeah, sometimes when they create these problems, the numbers that they give it don't actually match what you're seeing. And in this case, that's happening because they're saying that this bit here is 4 centimeters, which looks shorter than this side, even though it's saying it's 4 centimeters and it was 1. Anyway, we'll go with it. So 4 centimeters, 1 centimeter. Then you would also see it sticks out again on both sides, which is 4 centimeters, and that's 4 centimeters, and that's still 1 centimeter. Now, that is 12 by 1, which is the exact same as that. You know what? Yeah. Just shrink it a little bit just to make it look more the same. Okay? So does that kind of make a bit more sense to you? I hope it does. Anyway, we're gonna roll with it. So let's go. Let's go to front and back now. Front and back. We have here, and we have here. We have them twice because we have the front and the back. So the front and the back is equal to 2 times the length and width of the blue, or let's say the area of the blue, plus the area of the red, which is equal to 2 times the area of the blue is 12 centimeters by 1 centimeter. So we can say length times width. I'll do it out. I'll spell it out a little bit more. Plus length times width, because they are areas of a rectangle, which is equal to 2 times length times width of the blue, which is 12 times 1, plus 4 times 7. 4 times 7 is 28, plus 12 is 40, times 2 is 80. Let's just factor this out. 12 plus 4 times 7 times perfect, 80 centimeters squared. All right, now that there is meant to say left and right. Atrocious. Left and, for all of you who don't know, I should have said this earlier, that symbol means and. So left and right is equal to, again, we have two sides. Now, it's the exact same thing that has happening down here, where you have this face, you have this face. Now, what I can say is I know this length here is 1 centimeter. And I know that this height here is 7 centimeters. And I know that this height here is 1 centimeter. So I can then say that the area of this rectangle there is length times width, which is 1 plus 7, which is 1 plus 7 times 1, which is equal to 8 times 1, which is 8. Now, that's exactly what I'm going to do over here. I just wanted to show you where that works. It's as if I've just kind of taken these corners and I've extended them out to here. I've given myself that whole kind of shaded side there. So this is equal to 2 times the length times the width of that rectangle that I was looking at there. 2 times length times width, which is equal to 2 times 8 times 1, which is equal to 16 centimeters squared. Now, notice we can also do it separately, right? You can do this separately, where you can have a look at it, and you've got we have a look at our faces. You have there, and it would look like from that point of view, look like this. We have 1, 1, 7, and you can do them separately if that's how you would like to do it. You can say it is this area is equal to length times width of this section plus red, length times width of this section, which is equal to 1 times 1 plus 7 times 1, which is 8, which is where this number here came from. We just did it, and we assumed you kind of, could see it from a point of view. We kind of brought it out and just calculated it as one big rectangle. It's the same thing we're going to do when we're viewing the top and the bottom, right? Because when you look at the top, this pencil's so nice to draw with. It's really drawing with the iPad is a lot of fun. You have this here. Now, if you look at it from a front-on view, that looks like this. I'll draw it in this color too. Looks like that, right? A 12 by 1 rectangle. Now, if you looked at the bottom, we'll go through it again. We went through it before, but and you could kind of draw it out. You would see, looked at it from the bottom, you would see that same rectangle down there. Or imagine if you casted, like if you had a light shining on it, and that light was, directly above it from up here, shining down. This pink bit would be the shadow, right? Which is cool, huh? And that kind of also looks like the surface area. Anyway, so this little bottom bit, when we were looking at it, is made up of 3 different blocks. We have here, this block here this is 1 centimeter, and we found out before this is 4 centimeters. So we have a 1 by 4 centimeter block. Again, we have another 1 by 4 centimeter block. And then again here, this is 4, this is 1. We have another 4 by 1 centimeter block. So the addition of these is 12, which is the exact same thing we have at the top. So we're going to do it just as the rectangle. Now we have the front, the top, and the bottom. So that is equal to 2 times our rectangle, which we calculated. The area of a rectangle is length times width. Now, we figured out that our length is 12 and our width is 1. 2 times 12 times 1 is 24 centimeters squared. Beautiful. And so that means our total surface area is the addition of the top and the bottom plus the left and the right plus the front and the back, which is equal to 120. Let's just make sure I'm right. Yes. There's your answer. All right, final question. So this is really cool. This is a really cool problem. It is a harder problem. Okay, so this is getting into the territories of B's and A's here. This is an interesting problem because there's multiple ways you can attempt it, but if you're using the formula for a cylinder, you need to understand that you're only looking at part of a cylinder, right? The part of the cylinder that you're looking at is here. Now, this is 3/4 of a face. If you split it up, let's use my pencil again. You have 1/4, 2/4, 3/4. So we are looking at 3/4 of a cylinder, which means that our surface area is equal to 3/4 times the surface area of a cylinder. Now, the really cool part about this is you need to recognize that when you're only doing part of the surface area of a cylinder, what it's forgetting to do is it's forgetting to include these faces here, right? So you can't just do that. You also need to add these in, okay? Because when you the 3/4 of the cylinder, what it's doing is it's technically just kind of opening it up, but it's not kind of adding anything into it where you now have these solid flat faces, okay? So you have these two parts here. Now notice, because we are talking about circles here, they haven't bothered to put in these little dashes to indicate that these are both the same size. Now, these are the radius of a circle. So they're both of length 5 centimeters, and they both have a height or the depth of 15 centimeters. Very cool. So then we're going to add over here, plus we have two of those faces to the area of our rectangles. All right, so let's draw it all out. Here, this is equal to 3/4 times the surface area of a cylinder, which is 2 times pi times r squared. Let's do it actually. 2 times pi times r squared plus 2 times pi times r times h plus, we've got to remember, our 2 times the length of the width of our rectangles. Now we can substitute in all of our values now. So 3/4. Oh, that's cool. Did a little dotted line. I wonder how I did that. Anyway, times 2 times pi times our radius, which is stated as 5. So 5 squared. Remember, one of them is squared, one of them is not, because one of them is talking about the area of the face of the circle, which is what pi r squared, and then one of them, in terms of your like the surface area of a cylinder, is talking about the circumference of a circle multiplied by the height, which kind of gives you that ring and that rectangle that makes up the base, not the base, the length of your cylinder. Because you got your two faces, and then you got that bit that's all around it, which is this bit right here, right there. Yeah. I could go into it more. We went into class, but basically, a bit of a sidetrack. Looks like this. You have your two faces, and then this bit here, I won't do it in pink. This bit here is what would happen. It's like this is a net. If you folded that all up and you wrap that around, you would get a cylinder. So that bit here is this bit in there. Anyway, so 2 times pi times 5 squared plus 2 times pi times 5 times the height, which is 12, plus the area of the rectangle, which is 2 times our length times our width, which is 5 and 15. All right, now we can just plug this into a calculator. Now, it is a lot to do at one time. If you wanted, you can do it all in different parts. I'm just going to do it all at once. So, 3/4. Now, if you don't know how to put 3/4 into a calculator, you can put in 3 divided by 4 and click equals, and then you can just use your answer and multiply that way. But there is a button, and it looks exactly like a fraction. It is this one box, a line, and then an empty box. You click it, it will give you fractions. You need to use those kind of the arrow pad to shift in between the different boxes, and you need help out of it to keep going. Times 2 times pi times 5 squared plus 2 times pi times 5 times 12 plus 2 times 5 times 15 is equal to 644.8 centimeters squared. That there is our final answer of all of it. We are done. Fantastic work, everyone.